In this problem, we are trying to find the longest consecutive sequence in a given nums array. And nums array is not sorted, so in this example, you can see that 1, 2, 3, 4, these are consecutive numbers, and the size is 4. So that's what we should return. And since it is not sorted, there's a way of like there could be so many ways of solving this, and where we could sort this and then compare that. But any type of sorting is O n log n, or brute force, where we were taking one and comparing it and doing all this calculations in there. That is also like at least O n square or worse than that. In here, it is asking us to solve it in O of n. What is the best way to group all these numbers together? In this problem, union find data structure is the best suit, because we could group them all together and count their size and keep track of the size. So let's jump into implementation of it. So union find, and here we will need to have our map of integer to integer, where we'll be keeping track of its parent, and map integer to integer, where this will be having our rank, where we will need to keep track of its size and how many nodes does it have, and to have our max length. Let's initiate our constructor, union find, and this will take the nums array, and let's initiate our parent, new hash map, our rank, new hash map, and let's go over this num and assign for parent. Let's put for num itself. So in the beginning, given num, it's a parent to itself, and in the rank, for given num, we'll add 1. So basically, in the beginning, all these ranks will have 1, number 1, because like it's node itself, we're counting the node itself, and we'll be keep counting the nodes in here. So let's do max length. In the beginning, it's just 1, because like there's only one node. So max length, where so this is our constructor, and let's define our methods, because like it's a union find, where we have two methods, union and find. So let's do our find method. So for given vertex, let's find its parent. So if in our parent get v is not equals to v, then recursively call and then put for v our find parents get v. So the goal is to find the given vertex's parent. So sometimes like it could not be the same. In that case, like we will find the parent for v's parents parent, and then if it's not that one, then it's parent, because like we need to find its representative. At the end, return parent get v. So this will contain the parent and public. So we need to define our union. So union will be for v1 and two vertices. Basically, we'll try to connect them, and let's get this parent. So v1 find v1, and p2 find v2. So when p1 and p2 they are equal to each other, then there's a cycle, so we don't want to include that. Then when p1 is not equal to p2, then do all these operations in here. And then this rank, we could find help use this rank to figure out to which part of the node we need to attach which ones. So the parent, which has smaller nodes, needs to get attached to the parent that has larger nodes. So if in our rank get p1, so let's say if p1 is greater than p2, this means that p1 is a parent of p2. In that case, what we should do? So in that case, for parent, you can say put. So p1 is a parent of p2. So for p2, add the parent of p1. p1 is greater than p2, which means this is a parent, and for p2 we need to add the parent of p1. And for rank we need to do put. So for p, because like p1 became a parent, then we need to add the rank of p1 plus rank of p2. Then we'll need to update our max length equals to max length, and against we can say from rank get now p1, because this p1 will get the rank of it and then try to keep track of which is the larger one, and then we'll need to do the same thing for when this is not the when p2 is smaller than p1. So here we see that there is a repetitive code. We could actually extract this and put it here, because like it will be repetitive for both of them. And then what could we do is that let's change this part, because like this will be applicable to the other way. And then you can say temporary save p1 here, and then we'll say p2 is equals to p1, and so now p2 and p1 became 1. Then p1 needs to be, we need to save p2. So now we're saying p2 equals to p1, and p2's value got changed, but we have saved in temporarily to, because like we need to swap them basically. So and that's about it in this union. Now we could take care of some edge cases in here. When num's length equals to 0, then we'll need to return 0, because our max length we initiated to be 1, and we don't want to return 1 when nums is 0. So for int num in nums, what we are going to do is that we will check if given let's create our union find object. union find, and let's give our nums. So it has been located in here, and we need to check if this given num is in our parent, in this parent right here. So let's create some getter. Probably get parent, so return parent. So for uv get parent, so which is a map contains key of num. If it contains key of the num, we can actually check the num plus 1, because we are trying to see if num plus 1 is in this key, because num is already, we have defined it here, we're adding num already in this our parent, but our goal is to figure out if there is a consequence number in this. So we're saying if in our parent contains this consequence number, then let's form a union. So we will send our num and num plus 1. And it will just go through all those things and then do all those calculations in here and then keep track of this map lengths. We can actually create a getter for it as well. Get max length. So return max length. And in the end, because like it will be keep tracking of this number right here, and in the end all we need to do is just return get length. So let's run our code. Perfect. There we go. So in this problem, we have tackled the solved this problem in O(n) time.